Imagine you step outside on a clear night. You look up at the stars. Everything looks the same as it always has. Orion is there, the hunter, the constellation you have known since childhood. And in his shoulder, a star, a reddish, slightly orange star, brighter than most. You have seen it 1,000 times. You do not know that it is dying. Betelgeuse is one of the largest stars in the observable universe. If you placed it where our sun is, its surface would extend past the orbit of Jupiter. Jupiter, the planet so large that 1,300 Earths fit inside it, would be swallowed entirely. The star is so large that if you tried to drive around its equator at highway speed, it would take you over 2,000 years to complete the journey. It is a red supergiant, a star in the final chapter of its existence. And it is close. Astronomically, terrifyingly close. But here's the problem. Betelgeuse is not just large, it is unstable. In late 2019, something happened that sent shockwaves through the astronomy community. Betelgeuse began to dim. Dramatically, it faded to about 40% of its normal brightness, so much that it became noticeably fainter to the naked eye. Astronomers around the world pointed their telescopes at it. Theories multiplied. Papers were written. The phrase imminent supernova appeared in serious scientific publications. The event became known as the Great Dimming, and for a few months the question was not theoretical. The question was, is it happening right now? It was not, at least not then. The dimming turned out to be caused by a massive eruption of stellar material that cooled and condensed into a cloud of dust, temporarily blocking the star's light, the largest stellar eruption ever directly observed, a star sneezing out material the size of our entire inner solar system. But here is what the Great Dimming told us. Betelgeuse is not a stable star quietly burning in the night sky. It is a churning, pulsating, erupting giant in the final stages of its life. It varies in brightness. It changes shape. It pulses. It throws material into space at extraordinary rates. It is a star that is actively, visibly, measurably dying. And when it finally goes, it will not go quietly. When Betelgeuse explodes, it will become a supernova. The word does not capture what this means. A supernova is not an explosion in any sense that human experience has prepared you for. In the first few seconds of a supernova, a star releases more energy than our sun will produce in its entire 10 billion year lifetime. In the first 10 seconds, more energy than the sun produces in 10 billion years. The light from the explosion will travel outward at the speed of light. When it reaches Earth, and it will reach Earth, because Betelgeuse is only about 700 light years away, it will be visible in the daytime sky, not as a point of light, as a new object in the sky, bright enough to cast shadows at night, bright enough to read by, bright enough that it will be impossible to ignore for weeks or months. This will be the most dramatic astronomical event in recorded human history. The last supernova visible to the naked eye was observed in a neighboring galaxy. Betelgeuse is in our galaxy, in our cosmic backyard. The Betelgeuse supernova will be orders of magnitude more dramatic than anything any living human has ever seen in the night sky. But here's the real problem. When will it happen? The honest answer is, we do not know. Betelgeuse is expected to explode sometime in the next 100,000 years. That sounds like a long time, but in stellar terms, it is tomorrow. The star is showing the signs of a star approaching the end. The dimming, the pulsations, the mass ejections, the chemical composition of its outer layers, showing the products of advanced nuclear burning that only happens in stars near the end of their fuel supply. It could happen tonight. The star could be exploding right now, as you watch this, and we would not know for 700 years, because that is how long the light would take to reach us. It could happen in 1,000 years, in 10,000 years, in 100,000. We cannot predict it more precisely than that. A star the size of a solar system, containing more mass than 10 of our suns, burning through its fuel at a rate we can measure but cannot control. And we cannot tell you when it will end any more precisely than sometime between now and the distant future. The uncertainty is its own kind of terror. And here is where everything changes. What happens to Earth when Betelgeuse explodes? The good news, and there is good news, is that Betelgeuse is far enough away that the explosion will not destroy Earth. The critical distance for a supernova to cause mass extinction on Earth is generally estimated at around 25 to 50 light years. Betelgeuse is approximately 700 light years away. We are outside the kill zone. But outside the kill zone does not mean unaffected. The supernova will release an enormous flux of gamma rays and cosmic rays. The gamma ray burst from the explosion will travel outward, and when it reaches Earth, it will interact with the upper atmosphere. Models suggest it could cause measurable damage to the ozone layer, the thin shield of ozone molecules in the stratosphere that protects life on Earth from ultraviolet radiation. Not catastrophic damage, not extinction level damage, but measurable, real, potentially significant damage to a layer that every living thing on the surface of this planet depends on. The cosmic ray flux will be elevated for potentially thousands of years after the explosion. High energy particles from the supernova remnant accelerated to nearly the speed of light, streaming through our solar system for millennia. The long-term effects of this elevated cosmic ray environment on biology, on climate, on the atmosphere are not fully understood. But that's still not the worst part. The most terrifying thing about the Betelgeuse supernova is not what it will do to Earth physically. It is what it will reveal about the universe we live in. Betelgeuse will leave behind a remnant. When the outer layers are blasted away in the supernova explosion, the core will collapse. In a fraction of a second, a mass greater than our sun will be compressed into a sphere roughly 20 kilometers across. The density will be so extreme that the protons and electrons in the core will be forced together, combining into neutrons. What remains will be a neutron star, a city-sized object containing more mass than the sun, rotating dozens of times per second, emitting beams of radiation from its poles. Or, depending on the mass of the collapsing core, it will not form a neutron star at all. It will collapse directly into a black hole. The core will fall past the neutron star stage, past the point where neutron pressure can halt the collapse, and will simply keep falling into a singularity, into a black hole in our backyard, 700 light years away, a new black hole in the constellation Orion. There is one more thing about Betelgeuse that stays with you. The light we see from Betelgeuse left the star approximately 700 years ago. When that light departed, the star may have already been beginning the processes that lead to a supernova, or it may not have been. We cannot know. What we know is that we are seeing Betelgeuse as it was 700 years ago, not as it is now. Right now, at this moment, Betelgeuse may already have exploded. The light from that explosion may already be traveling toward Earth at the speed of light, crossing the 700 light years between us and the star, arriving at a moment we cannot predict. You might step outside tomorrow night and look at Orion, and the star that was in his shoulder, the reddish, familiar star you have seen 1,000 times, will be gone, replaced by something so bright you cannot look directly at it. A new sun in the night sky, the death of a star that began 700 years ago, arriving at your eyes tomorrow, or tonight, or in 1,000 years, or it already happened while you were reading this sentence. Here is what stays with you. The stars are not permanent. They are not the fixed, eternal backdrop that human intuition assumes them to be. They are objects, physical objects, subject to physical laws. They form, they burn, they exhaust their fuel, and they die. Some die quietly, white dwarfs cooling slowly over billions of years. Some die violently, in explosions that for a brief moment outshine entire galaxies. Betelgeuse will die violently. We know this. The only question is when. And when it does, a star that human beings have named, have navigated by, have included in their myths and stories and constellations for tens of thousands of years, will simply be gone. Orion will have no left shoulder. The hunter will be incomplete. The sky that has looked the same to every human being who has ever lived will be permanently, visibly, obviously different. For the first time in recorded human history, a familiar constellation will change shape. The sky our ancestors knew, the same sky, the same star, will be different. And every child born after the supernova will look up at Orion and see a hunter with a missing shoulder, and they will never know the sky that every human being before them knew. The universe is not static. It is not safe. It is not a backdrop. It is an active, violent, ongoing process, and occasionally, that process is visible from your backyard on a clear night. Look up at Orion tonight. Find the reddish star in his shoulder. Look at it carefully. You might be looking at it for the last time.